friends and students, welcome back once again. Today, we will be discussing one more important topic, that is about electric vehicle power source. Mainly in this, we will discuss about EV batteries. So we will deep dive next generation batteries for EVs, the future of electric vehicle power source. All right. So we will discuss more about this, but what are the challenges, current battery challenges we have to understand first. So there are limitation of lithium ion, that is the chemical which is used for the battery mainly in today's scenario. That is about cost, charging time, range. That means once you charge it and how long it gives, or how long the vehicle, or how long it will sustain. Resource, point number one. Second is lithium-ion batteries max output is about 250 to 300 watts per hour per kilogram. Limiting range, that is EV's range, most EVs, that is 200 to 350 miles. Okay, that will be the range approximately. It's going. Fast charging, that is 20 to 80% in 30 minutes. Because if you want to charge it, minimum 30 minutes it will take. Still large lags behind the gas refilling. Refilling you can do it. It is the internal combustion engine. It takes less than 5 minutes. That means you are saving time. Lithium cobalt, the third point is lithium cobalt and nickel prices fluctuate widely. Right? One estimate is that is it was 50K, that is $50,000 per ton in 2022. That is a research paper suggests us. Thermal, the next point is thermal runaway risk. Fire hazardous, of course it is fire hazard. And capacity loss, that is 20% over 8 years. Capacity loss will be there. This has been proven, or there are some research paper on this. Environmental concerns, mining, recycling, these are also one of the concerns. Mining lithium requires 500,000 gallons of water per ton of ore. That means it requires so much of water for this particular thing. Okay, on this particular topic or related topic, we'll have a small video. Please watch.
I'm sure you've heard the rumors. EV batteries wear out fast, they're impossible to recycle, and they're bad for the planet. Let's break down what's fact and what's fiction. First off, lifespan. Modern EV batteries are built to last. Most manufacturers guarantee 8 years or more, and real-world data shows many cars cruising well past 300,000 miles without major battery issues. That's longer than a lot of gas engines. Worried about degradation? Here's the truth. On average, batteries lose just 2 to 3% of their capacity per year. That means after a decade, your battery might still hold 80% of its original charge. Plenty for daily driving. What about recycling? Over 95% of an EV battery can be recycled or repurposed for things like home energy storage. And the tech is getting better every year. The biggest myth? That EV batteries are an environmental disaster. Yes, mining for materials has an impact. But it's shrinking fast thanks to new techniques and ethical sourcing. Plus, over a battery's lifetime, EVs still produce way fewer emissions than gas cars. So, next time you hear someone say EV batteries are just ticking time bombs, you'll know the real story is a lot more electrifying. Got questions? Drop them in the comments, and let's get real about the future of driving.
So the next topic we will be discussing about core innovations, that is replace liquid electrolyte with solid ceramic or polymer electrolytes. Solid ceramic. That's why we call it as a solid state. Okay. Liquid lithium ion inflammable, degrades over time, but solid state, no leakage, no thermal runaways. High energy density, that is 2 to 3 times than the lithium ion batteries. Enable 500 to 800 plus miles range. That is, we are talking about the range, the kilometer and the miles. What are the key benefits? Faster charging, potential 5 to 10 minutes for 80% charge. Safer, no risk, even in puncture. Safety, that is safety, no fire risk. That means if anything accident happens, puncture happen, burst, tire burst, but the safety will be there. Longer lifespan and lighter and smaller. So we'll watch one more video on this particular topic, and we will go to the next topic again.
Imagine a future where every mile you drive leaves zero footprint on the planet. For years we've heard that electric vehicles are the green solution for our roads. But here's the twist, most EV batteries aren't as eco-friendly as we wish. Mining for lithium and cobalt? It's messy, energy-hungry, and not so great for local communities. So, can we build a battery that's 100% green, from the first mineral to the last charge? Scientists think so. They're experimenting with new materials like sodium and even seaweed that are way more sustainable to source. Some startups are ditching toxic chemicals and creating batteries you can recycle over and over again. Others are exploring solid-state batteries that last longer and use less rare earth metals. But here's the challenge. Scaling up these ideas is tough. Costs need to drop, safety needs to rise, and we need to rethink the entire supply chain. Still, the race is on. And the breakthroughs are coming faster than ever. So, can EV batteries ever be 100% green? Maybe not today. But with every new discovery, we're getting closer to a future where clean driving truly means clean energy, from start to finish. Ready for a greener tomorrow? Hit subscribe to stay charged up on the latest in green tech.
Silicon and lithium batteries, that is lithium sulfur batteries. These are the latest technologies. That is sulfur battery, we call it silicon and lithium sulfur batteries. So silicon, but certain drawbacks are there. That is, silicon anodes higher capacity, but expansion issues are there. That means silicon anodes, it gives you a higher capacity, but expansion issue will be there. Lithium sulfur, lighter, cheaper, but shorter lifespan. Both the case in both the batteries, that is silicon anode as well as lithium sulfur, some drawbacks are there. Okay, so we'll go to the next slide. That is, we are discussing upon one more topic, that is sustainability and recycling. Closed loop recycling, redwood material, sodium-ion batteries, cheaper, no rare metals are used in this. So we are comparing again sodium batteries. Nowadays, in today's scenario, the recycling part is not that the batteries and all. So we will have a small video on this also. Please watch the video.
What if your electric car could outlast a road trip and charge faster than your phone? Let's peek into a future that's closer than you think. Picture this. New battery tech is smashing limits. Researchers are experimenting with advanced materials, stuff like solid-state batteries and crazy fast charging chemistry. The goal? 5-minute pit stops that fuel epic journeys, no more range anxiety, no more waiting around. Imagine driving coast to coast on a single charge, then topping up while you grab snacks. Sure, it's not on the market yet, but major breakthroughs are happening fast. If these innovations hit the road, everything changes how we travel, where we live, and how we think about energy. So, next time you worry about charging, remember the future might just blow your expectations away.
Here comes the road ahead. So that is, after this, what? Okay. Timeline for commercialization 2025 to 235, the timeline has been given. Impact, cheaper EVs, that is, the EVs will get cheaper with 500 plus miles range, grid storage. That means the storage will be like a grid. That means that is a lot of storage in the battery. The power in the battery will be stored. Okay, so we'll have one more video and we will end up with this. So this will give you a little idea about the EVs and the technology for the batteries.
If you want an EV but hate short ranges or sky-high prices, hang tight. Battery innovation is racing ahead, and big change is coming. In 2025, expect to see the first affordable electric cars with next-gen batteries, think sodium-ion and solid-state, rolling out in China and parts of Europe. By 2027, more models will hit US showrooms, featuring over 500 miles of range and fast charging. On top of that, these batteries will be key for storing solar and wind power on the grid, making renewable energy more reliable. So, if you're waiting for cheaper, longer-range EVs and better clean energy, mark your calendar. The future's charging up, and it's almost here.